Lucy is arranging 1 cent and 5 cent coins in rows. The pattern of coins in each row is as shown below. So we have 1 cent coin on row 1. In row 2 we have a 1 cent coin surrounded by two 5 cent coins. In row 3 we have essentially the same as row 2 actually, but 1 cent coins surrounding row 2. It appears to get row 4 we surround row 3 with 5 cent coins. So continuing this pattern, it appears that we take row 4 and surround it with 1 cent coins. So here I've copied row 4 and we need to just surround this row with 1 cent coins. The table below gives the number of coins and the total value of the coins in each row. Complete the table for rows 4 to 7. So let's look at row number 1. So the letter small n stands for each row. So for when n is 1, this column gives us the number of 1 cent coins, which is 1. This column gives us the number of 5 cent coins, which is 0. There are no 5 cent coins in row 1. This column gives us the total number of coins in the row. Well, there's just one coin in this row, and the total value appears in this column. So let's skip on to, say, row number 3. The number of 1 cent coins in row number 3 is 1, 2, 3. 3 of them. The number of 5 cent coins is 1, 2. The total number of coins in this row, row 3, is 1, 2, 3, 4, 5. And the total value of the coins in row 3 is 5 and 5 is 10. And the 3 ones gives us 13. Now, for row 4, we want the number of 1 cent coins, that's 1, 2, 3. The number of 5 cent coins in row 4 is 4. The total number of coins in row 4 is 1, 2, 3, 4, 5, 6, 7. The total value of coins in this row is, well, I could add up these numbers, but it should be clear that to get the sum of these numbers, we just take the sum of these numbers in row 3, which is 13, this number here, and add on 5 plus 5, which is 10. So we 13 plus 10 is 23. Let's look at row 5. How many 1 cent coins are there? Well, it's the same number of 1 cent coins as in row 4, but we add on 2 more. So 3 plus 2 is 5. How many 5 cent coins are there? Well, it's actually the same as row 4. It's 4 5 cent coins. What's the total number of coins in this row? Well, it's the number in row 4 plus 2 more. 7 plus 2 is 9. What's the total value? Well, it's the same as the value in row 4, which is 23 cent plus 1 plus 1, so we get 25 cent. Now, I'm not going to show row 6, but the number of 1 cent coins in row 6 will be the same as in row 5, because to get row 6 from row 5, we just add a 5 cent coin onto each side. So I won't bother drawing that out. So the number of 1 cent coins will remain the same as row 5, which is 5. The number of 5 cent coins will increase by 2, because we'll be adding a 5 cent coin onto each side. So we'll have 4 plus 2 is 6. The total number of coins is got by just adding these numbers. The number of 1 cent plus the number of 5 cent gives us the total number of coins, which is 11. What's the value? Well, the value is the same as in row 5, which is 25. But remember now, we have to add two 5 cent coins. So we have to add 10 cent onto 25 cent. That gives us 35 cent. Now, what about row 7? Well, for row 7, we'll have to add two 1 cent coins. So let's just, I won't try and confuse things here, but to get row 6, we add 5 cent coins to either side. To get row 7, we add 1 cent coins to either side. Okay, so the red and the green, the red gives us row 6 and the green gives us row 7. So the number of 1 cent coins in row 7 is the number in row 5 plus 2. See this 1 and this 1 here, that gives us 7. Number of 5-cent coins in row 7 is the same as in row 6 actually, no change, because to get row 7 we just added 1-cent coin onto either side. So we've 6 5-cent coins. The total number of coins, well, we just add these numbers together, 7 and 6, that's 13. And what about the value? Well, to get row 7 we had to add 1-cent coin and another 1-cent coin. So we add 2 onto 35, that gives us 37. Complete the following sentences to state in terms of n. Remember, n is the row number. The number of 1-cent and 5-cent coins in row n. Number 1. If n is odd, row n has how many 1-cent coins? So let's look at odd numbered rows. These are the odd numbered rows. So how many 1-cent coins have we? Well, if n is 1, we have 1 1-cent coin. If n is 3, we have 3 1-cent coins. If n is 5, we have 5 1-cent coins. So we can see that when n is odd, we have n 1-cent coins. So whatever n is, if n is 3, we have 3 1-cent coins. If n is 7, we have 7 1-cent coins. How many 5-cent coins have we? Well, if n is 1, we have 0 5-cent coins. If n is 3, we have 2 5-cent coins. If n is 5, we have 4 5-cent coins. If n is 7, we have 6. So we can see the pattern. The number of 5-cent coins is 1 less than the row number. So 0 is 1 less than 1 or 1 minus 1. 2 is 1 less than 3 or 3 minus 1. 4 is 5 minus 1. 6 is 7 minus 1. So when n is odd, say n is whatever n is, the number of 5-cent coins will be 1 less than n. Well, we write that as n minus 1. So for example, if n is 7, we will have 7 minus 1 or 6 5-cent coins. Now let's look at even values of n. I'll use a different color here. When n is 2 or 4 or 6, we have, these are even values. Well, row n has how many 1-cent coins? When n is 2, there are 1 1-cent coins. When n is 4, there are 3 1-cent coins. When n is 6, there are 5 1-cent coins. So you can see that the number of 1-cent coins is 1 less than the value of n when n is even. So if the row number is n, where n is an even number, the number of 1-cent coins will be n minus 1. So for example, if n is 6, 6 is even, then the number of 1-cent coins will be 6 minus 1, which is 5. How many 5-cent coins are there? Well, you might have guessed that the pattern is the reverse of the pattern for 1-cent coins. When n is even, the number of 5-cent coins is the same as n. So when n is 2, there are 2 5-cent coins. When n is 4, there are 4 5-cent coins, and so on. So there are n 5-cent coins when n is even. Part D. Find the total number of coins in the 40th row. Well, what's the total number of coins in any of these rows? Well, it's just got by adding these numbers together. In general, if n is odd, we just add the number of 1-cent coins, which will be n, onto the number of 5-cent coins, which is n minus 1. So we add n onto n minus 1, and that gives us the number of coins in row n when n is odd. But what is n plus n minus 1? Well, that's just 2n minus 1. And the same is true when n is even. You know, in the nth row where n is an even number, the total number of coins is got by adding up the number of 1-cent coins to the number of 5-cent coins. That's just n minus 1 plus n. But it's also 2n minus 1. So it doesn't matter whether n is even or odd. The sum is given by 2n minus 1. So for example, if n is 2, then the total number of kinds in the second row would be 2 times 2 is 4 minus 1, which is 3, this number here. If n was, say, 3, the total number of kinds would be 2 times 3 is 6, 6 minus 1 is 5. If n is 4, we have 2 times 4 is 8, 8 minus 1 is 7, and so on. So these numbers are actually follow an arithmetic sequence. See, the common difference is 2. 1 plus 2 is 3, 3 plus 2 is 5, 5 plus 2 is 7. So we're interested in the 40th row of this column here. So if n is equal to 40, well, we just plug 40 in for n. So we get 2 times 40 minus 1. That's 80 minus 1, which is 79. So there are 79 kinds in the 40th row. If you could imagine writing out 40 rows in this table. Part E, find the total value of the kinds in the 40th row. Okay, so n is 40. As we saw previously in part D, the number of kinds in the 40th row is 79. So we need to know the values of those kinds. Well, 40 is an even number. So we saw in C part 2 that if n is an even number, then that row has n minus 1 1 cent kinds. So that means we have 40 minus 1 1 cent kinds. Well, 40 minus 1 is 39. So we have 39 multiplied by 1 equals 39 cent. We have 39 cents worth of 1 cent kinds. We have n 5 cent kinds. Well, n is 40. So that means we have 40 5 cent kinds. Well, 40 multiplied by 5 is 200 cent. So we have 200 cents worth of 5 cent kinds. So I'm just following this here when n is even. So I'm just plugging 40 in for n. So row 40 has 40 minus 1 or 39 1 cent kinds, and it has 40 5 cent kinds. That's all I'm using here. So what's the total value? Well, we just add these two numbers together. So the value is 239 cent. So that's the answer to part E. Part F. Which row has kinds with a total value of 337 cent? So what we will do here is look for a formula for the total value. We have two cases to consider. One case is the case where the row number n is odd, because we saw from C part 1, if n is odd, then row n has n 1 cent kinds and n minus 1 5 cent kinds. So what will be the total value? We just multiply n by the value of a 1 cent kind, which is 1. So we have just n times 1, plus the number of 5 cent kinds, n minus 1, multiplied by the value of each kind, which is 5. So we have n minus 1 multiplied by 5. So we have n times 1. That's the value of the n 1 cent kinds. And the value of the n minus 1 5 cent kinds is n minus 1 multiplied by 5. We have to bracket n minus 1. See, there's two terms here. Multiplying all of this by 5. So this will give us the value of the kinds in an odd numbered row. So we can simplify this. We have 1n here, we'll get a 5n here, 1n plus 5n is 6n, and we'll have a minus 5. So that's the situation if the row number is odd. Now let's look at the situation where n is even. Well, if n is even, then we have n minus 1 1 cent kinds. So the value of them is the number of them times 1, the value of each kind. And we have to add on the value of the 5 cent kinds. We have n 5 cent kinds. So let's simplify this. We have a 1n here and we have a 5n. That gives us 6n. 1 times minus 1 is minus 1. Okay, in part F, we're given that the value is 337 cent. Now we don't know whether this row is odd or even. So let's just assume that it's odd. Let's see what we get if n is odd. Well, we put 6n minus 5 equal to 337. We solve it to find n. n will be the row number. Let's see what that gives us. 6n equals 337 plus 5, that's 342. So that means that n is 342 divided by 6, 6 5s are 30, and 4 over 6 7s are 42. See, this comes out to be an integer. So this is actually the correct answer. If we used the other formula, we would not get an integer value for n. That means that the row number that gives coins with a total value of 337 is odd, and its value is 57. To see that, let's suppose we don't know. It's just trial and error. We just have to try them out, really. Well, if n was even, we would be putting 6n minus 1 equal to 337, and if we try to solve this, we should find that we do not get an integer solution. We get 6n equals 338, which means that n is 338 divided by 6, 6 5s are 30, and 3 over 6 into 38 goes 6 times and 2 over. We get 56, and 2 6s are 56 and a third. So there is no such row as the 56 and 1/3 row. So that tells us that that doesn't work. In other words, n is certainly not even for this situation. So you just try each of these formulas. One of them will give an integer solution, the other one won't. So the answer to part F is that n is 57. The 57th row has coins with a total value of 337 cents. Find the total value of the coins in the first 40 rows. Well, this column here gives us the value of the coins in each row. Now, we could look at these values and see if there is a pattern. Well, we want to sum all of these numbers for 40 rows. Okay, we want the total value of the coins. In part E, we just got the value of the coins in the 40th row. Here we want to actually sum all these numbers down as far as the 40th row. If we look at this carefully, we will see that there's a pattern. 1 plus 10 gives us 11. And 10 plus 2 gives us 13. We also have to include that. The 1 is included twice, actually. We have 1 plus 1 plus 10. Okay, so we want to add 1 onto 11. Well, actually, come to think of it, I think there might be an easier way of looking at this. It turns out that this sequence of numbers, or series of numbers, consists of two arithmetic series. So we want to add up these numbers, but we see that these numbers here, every second number beginning with 1 follows an arithmetic series. So we have 1 plus 13 plus 25 plus 37, and we keep going. Now, how far do we go? That's the question. Anyway, I'll get back to this. The values I've circled in red, beginning with 1 and just taking every second term, is an arithmetic series, because 1 plus 12 is 13, 12 plus 13 is 25. 13 plus 12 is 25, 25 plus 12 is 37, and so on. The remaining terms also follow an arithmetic series. You can see that 11 plus 12 is 23, 23 plus 12 is 35, and so on. So we want to sum this series here, 40 terms of this series, but we can break it into two arithmetic series. What's the last term of this green series going to be? I could call it the green series. Well, it's going to be the 40th term, because these are the even terms. This is the second, this is the fourth, this is the sixth, and we keep going up to the 40th term. Now we've already worked out the value of the kinds in the 40th row. That was part E. If you think back, what was it again? If n is even, we have n minus 1 1 cent and n 5 cents. So if n is 40, we have 40 minus 1 1 cent kinds, or 39 1 cent kinds, and we have 45 cent kinds. So that's 39 cent plus 40 times 5. 39 plus 200 is 239. So the last term in the green series, and indeed in the entire series, is 239. So how many terms are there here? Well, if you think about it, there's exactly 20 terms, because I start off by circling n equals 2, then n equals 4, n equals 6. So we have 20 terms here. So we can now sum this series. The sum of a series Sn is n over 2 into 2a plus n minus 1 times d. That's the formula for the sum of an arithmetic series. Now this n has nothing to do with this n here, of course. This n is just the number of terms in this series. There are 20 terms in the series, so we want S20. So 20 divided by 2 into 2 times a. Well, a is the first term, which is 11. 2 11s are 22, plus n minus 1 is 20 minus 1, which is 19, times the common difference here. D here is 12. We get the value 2,500 cent. Now let's look at this other series. The red series consists of the odd numbered terms. Well, how many terms are in this series? Well, again, there must be 20 terms. If there's 20 terms in the green series, well, there must be 20 in the red, because the total is 40. 20 plus 20 is 40. So n is 20. The common difference is actually 12. So we use Sn, this formula here. You can look this up. So we want S20. So we have 20 over 2 into 2a, where a in this case, the first term here, is 1, plus 20 minus 1, which is 19, times d, which is 12. Calculating this, we get 2,300. So now we can write down the answer. The answer is 2,300 plus 2,500. So the total value of the kinds in the 40 rows is 4,800 cent, which is 48 euros.